To maximize trans-equatorial propagation on 6 meters, you need an antenna that does two things exceptionally well. Focuses energy towards the horizon, that is low angle of radiation, and provides significant forward gain to punch through the ionosphere. Trans-equatorial propagation signals often arrive at very low elevation angles, sometimes less than 10 degrees. Stacked Yagis, the ultimate TEP weapon. If you have the space and a sturdy tower, stacking two Yagi antennas is the gold standard for low-angle DX work. By placing two identical Yagis, one above the other, and feeding them in phase, you compress the vertical radiation pattern. While stacking provides a modest increase in forward gain, typically 2 to 2.5 decibels over a single Yagi, its real magic for trans-equatorial propagation is lowering the main radiation lobe. A single Yagi at one wavelength height might have a main lobe at 15 degrees. Stacking can push that main lobe down to around 11 degrees, which is perfect for trans-equatorial propagation. The catch: on 6 meter, the optimal spacing between stacked Yagis is 12 to 16 feet, that is 3.5 to 5 meters. You need a substantial mast and rotor system to handle the wind load and the physical size. The 6 meter Moxon rectangle, high performance compact size. If a massive stacked Yagi array isn't feasible, the Moxon rectangle is a fantastic, highly efficient alternative. It is essentially a two-element Yagi with the ends of the elements folded back towards each other. A well-built Moxon offers around 5.5 dBi of forward gain and a massive front-to-back ratio often exceeding 25 dB. This directivity helps reject noise from the rear while focusing your RF energy towards the equatorial ionization crest. Height is the key. Like any horizontal antenna, getting a Moxon high in the air is crucial for lowering the radiation angle. You want it at least 1 to 1.5 wavelengths high, that is 20 to 30 feet, to get the angle low enough for effective trans-equatorial propagation. They are incredibly easy to homebrew using wire and fiberglass spreaders or aluminum tubing for a more permanent installation. Because it is compact, a 6 meter Moxon is only about 7 feet wide. It has a much smaller turning radius than a comparable Yagi. The 6 meter halo, the omnidirectional compromise. If you lack the ability to rotate a directional antenna, a halo antenna is a viable option. It is essentially a half-wave dipole bent into a circle or square. When mounted at a sufficient height, at least 10 to 12 feet, ideally higher, a halo provides a single low-angle radiation lobe that extends 360 degrees. It is horizontally polarized, which matches the standard for 6 meter SSB and digital modes. The catch: it is an omnidirectional antenna, meaning it lacks the forward gain of a Moxon or Yagi. You will be relying entirely on your radio's output to make the trip rather than multiplying your effective radiated power with a directional beam. However, for a simple non-rotating setup, it performs surprisingly well. For the specific goal of maximizing trans-equatorial propagation from my region, a Moxon placed as high as possible is likely the best balance of high performance, manageable size, and homebrew feasibility.